Question 2. The proportion of houses in Radville which are unable to receive digital radio is 25%. In a survey of a random sample of 30 houses taken from Radville, the number, which we'll refer to as X, of houses which are unable to receive digital radio is recorded. Find the probability that X is in between 5 and 11. We're including 5, we are not including 11. Okay, a few things to spot in the question. Firstly, I've been told a proportion, 25%. So the proportion of houses in Radville unable to receive digital radio is 25%. In a survey of the random sample of 30, so I know the sample size, which will be my N value, and hopefully you've spotted by now we are working with a binomial distribution. Okay, X follows a binomial where N equals 30 and P equals 0.25. Let's be very clear exactly what P represents. P is the proportion of houses that are unable to receive digital radio. Alright, so P is houses unable to receive Okay, let's get back to the probability. Firstly, I want to write both of these statements inclusively, so I would prefer to see an equivalent probability statement as such. What we're going to do, we're going to start with the probability that X is less than or equal to 10. So that will include everything below the value of 10. What we need to eliminate to make sure that we match the probability statement above is everything below 4. Okay, a common and a rookie mistake to be made here is people subtracting everything 5 and below, which is actually not going to match the probability statement that we're looking for. Another mistake is for people to start working with the probability that X is greater than or equal to 5, which is not quite what this probability statement is asking for. The technique here is to have everything less than or equal to 10 as a starting point, and then to remove everything less than or equal to 4, which actually will leave you with the probability that you're looking for, which is the probability that X is in between 5 and 10. Let's make ourselves some more space. Looking that up in the tables, we are going to get of 0.8943 minus 0.0979. Easily done on the calculator. Gets us a final answer of 0.7964. The probability that X is in between 5 and 11, including 5 but not including 11, is 0.7964. Okay, moving on to the next part of the question. Here we're told a radio company claims that a new transmitter set up in Radville will reduce the proportion of houses which are unable to receive digital radio. After a new transmitter has been set up, a random sample of 15 houses is taken, of which one house is unable to receive digital radio. What's important to note in this question? What is the claim of the radio company? So we're dealing with a hypothesis test here. What is the claim of the radio company? It's that their transmitter will reduce the proportion of houses unable to receive digital radio. The sample size is going to be 15. And the observed value is just one house. Okay. Reading part B. Test at the 10% level of significance. Definitely a hypothesis test. Here's our significance level. Test at the 10% level of significance. The radio companies claim, state your hypotheses clearly. Okay, we'll start with the null hypothesis. We'll start with the null hypothesis. H0. H0 says that the p-value, the probability, is actually going to be equal to what we originally thought, or what the status quo was, what was originally advertised. Everything seems to be normal. The company's claim is actually going to be H1. Be extremely careful here. The company's claim is that they will reduce this proportion. This is a one-tailed test. H1 is the company's claim. Another rookie mistake is people thinking that the company's claim is always H0. That is not the case. Okay, so I'm making it clear to myself which of the two hypotheses is the company's claim. Also, right off the bat, we want to state the distribution that we're working with. So I'm going for a binomial where n equals 15. We're assuming that the probability is 0.25. And we like to find the expectation from here. The expectation is n multiplied by p, which should give us 3.75. Significance level is 10%. Be careful to check that. It usually is 5%, but it can be anything that the examiner wants to choose, and this time they've chosen 10%. Okay, we're ready to go with the hypothesis test. We want to find a probability, and that probability is going to use the observed value of 1. We want to find a probability that this, or an outcome more extreme than this, is going to occur. Firstly, let's make sure that we go in the right direction. One tip is to make sure that this probability statement does not include the expectation. With the expectation being 3.75, this will surely have to be less than or equal to 1. If this probability, which has the observed value and everything smaller than the observed value, ends up being smaller than our significance level of 10%, 0.1, then we have a significant result and we can reject H0. Let's go ahead and find out what the value is. So, probability that x is less than or equal to 1, we can look this up in the tables, is 0.0802. I'm going to make a quick comparison. This does end up being smaller than 0.1, which means we have a significant result. With the result being significant, that leads to us wanting to reject H0. So I have enough evidence to reject H0. And that is my mathematical conclusion. Let's have a think about this in context. H1 was the company's claim, which was that their new transmitter would reduce the amount of people unable to receive the radio signal. H0 said that actually their transmitter would be exactly the same as previously thought. I'm rejecting H0, so I have my contextual conclusion. There is enough evidence that the new transmitter does reduce the proportion of houses unable to receive digital radio. Be careful not to just assume that H0 is the company's claim. Another rookie mistake, students, when rejecting H0, automatically say the company's claim is false. This was not the case for this question.